Good evening, everyone. My name is MAHITha KOTHAPALLI, and I'm excited to present on the topic text summarization and question answering. Advancing the way we retrieve and understand information. In today's world, information is everywhere. But the challenge lies in accessing what's most relevant efficiently and accurately. This presentation explores how advanced techniques like summarization and question answering are transforming the field of information retrieval. What is information retrieval? Let's start with the basics. Information retrieval is the process of obtaining relevant information from a large repository. Typically, unstructured texted data like documents, websites, or emails. Traditional AI systems like early search engines relied on keyword based retrieval. You type a query and the system matches your words with those in documents. However, this approach often leads to irrelevant results, especially if users don't know the right keywords. Modern IR has evolved to include semantic search, user intent modeling, and contextual understanding. This shift makes IR not just a tool for finding information, but just a system for understanding what the user truly wants. What are these two areas important? The amount of text data is exploding. Think about daily news articles, research papers, customer reviews, medical records, and even chat logs. In this era of information overload, people don't want to read dozens of pages to find what they need. They want direct, concise, relevant answers. There is where text summarization and question answering become crucial. They help condense information, exact what matters most, and even generate responses to specific queries and not even for saving time and improving decision making. Why are these are two areas are more important? Let's look deeper in how these technology helps. In healthcare, summarization tools help doctors quickly understand patient histories. In business, meeting transcripts can be condensed into highlights for faster decision making. In education, summarization turns large textbooks into digestible study guides. The benefits go beyond just time saving. They reduce cognitive overload, improve information retention, and ensure users are focusing on what truly matters. And also understanding it faster and more efficiently, the average global temperature and the academic papers or news articles. Extractive versus abstractive. There are two major types of summarization. Extractive summarization acts like a smart highlighter. It selects the most important sentences or phrases directly from the text. It's useful when preserving the original wording is important. Coming to abstractive summarization, on the other hand, paraphrases content, it generates entirely new sentences while retaining the meaning like how a human would write a summary. It reduces cognitive load and enhances information retention by highlighting what truly matters. Abstractive methods are more flexible but are also more complex, often relying on deep learning models like transformers. Next, my teammate Akash YALLAMELI gonna continue the next slides.
So, hello. So, this is Akash YALLAMELI. I'm going to present the next few slides. So, we're going to discuss about uh, what makes information retrieval powerful. Like, there are so many questions arising. Like, sometimes it provides direct answers with the precision. Like, question answering system takes a step further, and users don't need to read anything. they can ask any question and receive direct relevant response from the system. Like we have shown the architecture here, like we ask a question, then the document retriever retrieves the relevant documents, and then it produces the answer from the from resourcing the knowledge source. So this is a critical and time sensitive scenario. So we get the customer support and legal queries and on demand knowledge access from the uh, question answer systems. So question answering system helps bridge the gap between human language and machine readable information. So the question answering is an open domain source. Like you can answer questions with any topic by searching it across the different domains, like Wikipedia or something. And also the open domain and closed domain are something that's really uh, these are the systems that are more flexible and widely used in the general purpose assistants like ChatGPT and Google search. So questioning answering systems goes a step further and then summarizes the instead of reading the document or its summary, users can simply ask a question and get a direct answer. This is incredibly useful in time sensitive situations like customer service, emergency responses, and legal research. So like the now in questioning answering system, we have open domain and closed domain. So the questioning answering systems can be divided into open domain, where these answer questions on any topic using large general data sets like Wikipedia, virtual assistants, and Google Assistant and ChatGPT, and they use these models to answer the questions. And in closed domain questioning answering system, these are really trained on specific topics like medical literature and legal text. So they offer a and higher precision in their domain, but can't answer questions outside it. Like both types are used in tools like search engines, healthcare, artificial intelligence, educational bots, and customer service platforms. And QA systems are used in search engines, voice assistants, customer support bots, and even education and healthcare to provide rapid, accurate responses. They represent a significant step forward in making information accessible to any conversations. And now we are discussing about transformer architecture for question answering systems like ChatGPT. So in here, like context awareness is really important in a QA system. Like it is one of the example for the QA system. Like context matters in real life conversation. We rarely repeat ourselves fully. For example, a user might say, "I'm looking for a hotel in New York with a pool." Then they ask, "Does it have a parking?" A good QA system understands the second question and refers to the hotel mentioned in the first sentence. This is achieved through attention mechanisms and context tracking. Especially in models like ChatGPT and BERT, such systems are becoming better at handling dialogue, not just a standalone question. So, so there are some benefits like this allows ChatGPT to capture context, recognizing dependencies, and maintain coherence across long conversations, improving response, relevance, and flow. So now we discuss the challenges in QA, question answering systems. While QA systems have made impressive progress, they still face several challenges that affects their accuracy, reliability, overall usefulness. So like ambiguity, context tracking, answerability, bias, and hallucination. So these models are really these challenges are like despite there are so many strengths, QA systems face several challenges. So in ambiguity, some questions can have multiple meanings, so it shows multiple interpretations. And in context tracking, multi-turn conversations, like multiple questions arrive and they require memory for prior context. So uh, it also affects coherence. And so in answerability, some questions have no answer, but the data set provides some fabricated one answers and may not have a clear answer in data. Hallucination and bias, models may generate confident but incorrect answers, but sometimes models generate different understanding and mitigations challenges in modern research. So now, handling ambiguity like and bias. Let's explore two specific decisions. uh, to specific decisions um, more deeply. Uh, Ambiguity questions like what is Java? Could you refer to programming language or an island? Systems need to use context or follow-up questions clarity. ChatGPT sometimes struggles to clarify ambiguous queries because it leads to response that don't fully address the user intended meanings. So IR uses these techniques like reference resolution and word sense disambiguation because it handles ambiguous languages and allow models to accurately interpret the meaning. However, ChatGPT may not always prompt for clarification or any other misaligned responses of ambiguity. So here it shows the model prediction uh, architecture like we use correct ambiguous query which clarification request, and then sometimes it have incorrect predictions, and in unambiguous query we have correct prediction, and sometimes we have incorrect prediction with also we have incorrect clarification request. So now evolution of information retrieval. So the traditional methods in bias in language, AI can reflect different bias found in its training data. So earlier in IR systems before 2000 were rule based, that they followed manually crafted logic, like if a user types X, return document Y. So these systems relied solely on keyword matches. There was no understanding of meaning or user interest. They were rigid and brittle. If you didn't use the exact keyword, the system didn't work. So in bias language, there are challenges like ChatGPT responses can reflect biases present in its training data, inadvertently generating language that may be biased or ethically problematic. So this manifests a subtle way in which stereotyping and pose challenges in sensitive contexts. So the IR concept. These techniques use bias mitigation and control text generation to focus on information retrieval to reduce unintended biases in language models. So these advances eliminates bias completely and remains unchallenging and challenging due to the complexity of human language. Yeah, so evolution of IR techniques. These traditional IR techniques are based on models, queries, similarity computation, and documents. In the earlier system, everything was manually coded, but now It is the rules that relied on exact keywords. So these systems are rigid, brittle, and didn't even scale well to open-ended and nuanced questions. So now I'll hand over to my friend Anupama. She will be presenting the rest of the slides. Thank you.
So I'm Anupama and I'll continue the rest of the slides. And now coming to the evolution and statistical models. So during the 2000s, statistical models are improved like two major ones. So the first one comes TF-IDF, which measured how important a word in a document relative to the corpus. And the next one is BM25, which extended IDF by accounting them for the frequency saturation and the document length. So these methods provided better relevance ranking, but still lacked deep schematic understanding. So coming to the next one, the evolution and neural model transformations. So since 2015, neural networks began revolutionizing. So early models like LSTMs and CNS could understand sentence structure better. But now the game changer was transformer. So this architecture introduced by Vaswani ET in the year 2017. So the models like BERT, T5, and GPT brought real contextual understanding and language generation capabilities. Now IR systems can match user queries with internet and meaning just like the keywords. So connecting to the IR goals. Today's IR systems aim for more than just retrieval. They focus on understanding and action. So QA provides direct answers but not just links. So coming to the efficiency, summarization reduces the time of reading and natural interaction. Conversational AI makes IR more human-like. So context awareness, it's like the systems track what users want, not just what they say. So the result is better user experience, faster insights, and smarter decision making. And coming to the emerging trends, the future of IR includes some exciting trends. So the first one would be multimodal IR, systems that understand the text, images, and audios altogether. Now, few shot and zero shot learning is the models that GPT-4 that generalize with little training data. Conversational retrieval agents. Think of think of research assistants that converse with while pulling information from multiple sources. So, the advantages push IR from statistic search to dynamic, intelligent information and interaction. Then, coming to the recap, to summarize, we explored the foundations of information retrieval and we understood how summarization and QA enhance IR systems. We looked at all the types, challenges, evolution, and real world uses. So, finally, we touched on cutting edge trends shaping the world of IR future. So, these tools are not just technical achievements, but they are reshaping how we want to interact the knowledge. Coming to the references, here are the sources and foundational works that inform this presentation from the creators of BERT, T5, GPT to studies in summarization of QA. Finally, I conclude that in a world overflowing with information, tools like text summarization and questioning answering are transforming how we access and understand knowledge. By moving beyond simple keyword, model information retrieval systems are becoming faster, smarter, and more user friendly, helping us get the right information with the right time. As these technologies continue to evolve, they hold the potential to revolutionize education, healthcare, business, and beyond. Thank you.